Two plane figures are going to be congruent if and only if one can be obtained by the other in a sequence of rigid transformations. So those are the ones that don't change the sign, right? Translation, reflection, rotation, all stays congruent. Okay? So it says that a landscape architect used a grid to design the landscape around a mall. And they have it over here on some tracing paper to confirm that the landscape elements are congruent. So it says they want us to trace the planter A, B, C, D. Describe a transformation you can use to move the tracing paper so that A, B, C, D is mapped onto E, F, G, H. And what does this confirm about our planters? Okay, so what we're doing is trying to figure out how far it is from one to the next. So you just need to pick one point and then its corresponding point and count how far apart they are. So if I start with point A, which point corresponds with it in the other figure? E. Okay? All right, so I'm going to have to move so many points this direction. How many? 4. And then so many points down. How many? 4. And that should be our translation, right? So our translation would be x plus 4, y minus 4, right? Okay, so they want to know what this confirms. So just above that, they said that if we were just translating, reflecting, and or rotating, the figure would stay congruent. Is that true here?
Yes.
Yes. So that's going to be our conclusion, or what we can gather. This confirms congruence. Remember, that's our symbol for congruency if you want to use it. Because translations preserve congruence. Okay? All right. On part B. It says to trace the pools JKLM and NPQR, fold the paper so that pool JKLM is mapped onto pool NPQR. Okay? You don't actually have to fold your paper, but if you were to fold your paper and you wanted these two to end up right on top of each other, what kind of a line would I be folding on? Would it be horizontal, vertical, diagonal? Okay. All right, so I would count to see where the middle of these points are, like where I would want them to meet up, right? That would be right in between K and P, right? So my diagonal line must go through that point. Okay? So here is our line of reflection. Well, what line is that? Y equals X. Very good. So this is reflection over Y equals X. Okay? So, do we know if they're congruent or not? Yes, they are, right? Because this was a type of transformation that does hold congruency. So, we would say the pools are congruent. Because reflections preserve congruency. Figure C says, determine whether the lines are congruent. Is there a rigid transformation that maps triangle LMN to triangle DEF? What does this confirm about the lines? Okay. So, are these congruent? No. Well, we have to come up with a way that we can prove that. Okay, so we're going to come up with our scale factor so that we can show what it's been changed by. Okay, so the difficult thing about this is that none of these are along straight units, right? And I should know that the distance across the side of something is not the same as the distance to go diagonally across it, right? So I can't just count my units here. But if we could figure out how far it is from here to here and here to here, that would give me my scale factor, right? Okay. So, do we have a formula that tells us how far something is from one point to another? The distance formula, right? Okay. So, distance formula is our coordinate point formula, right, with our x and our y's. Okay, so distance is equal to the square root. Okay, so what I'm going to do is just compare here so that we don't have to actually do it for all the coordinate points. How much up and over? How much up did I have to go to get 4? And then over, okay, over here, what would it be? 2 and 1. Okay, so we should be able to use the 4 and 2 as like our x and our y. So we're going to use 4 squared plus 2 squared over here. Well, what is 4 squared? 16. What's 2 squared? What is 16 plus 4? 20. Square root of 20. Can I simplify that any? Yeah, what multiplies to give me 20 that has a square root? 4 times 5 and the square root of 4 is, okay, so this is 2 square root of 5. All right, I'm going to do the same thing for this size over here. So underneath there, I'm going to have 2 squared plus 1 squared. Well, what is 2 squared? 4. What's 1 squared? 1. What's 4 plus 1? Can I simplify that any? No. But how much bigger is this one than that one? 2. So it must have been in either, well, it says that LMN is being mapped to this one, right? So this must be the original, while DEF is the new. Okay, and we always put new over old. Okay, so I would have square root of 5 over 2 square root of 5 to find my scale factor. What happens to the square root of 5? They divide out, so I'm left with 1 over 2. Right? So we just proved that it did shrink by a scale factor of 1/2. Okay? So dilation with K equal to 1/2. Okay? Alright, so then it says, how do the sizes of the pairs of figures help to determine if they are congruent? So on any of these, how did that help us determine it? Alright, the points matched up. Right, then they ended up being the same shape. The only time it wasn't was right here, right? So if we can prove that one of the figures is larger or smaller than the other, then that's going to mean that our shapes are not congruent. Okay? So larger or smaller images means shapes aren't congruent. Okay, on this next page, it it says use the definition of congruence to decide whether the two figures are congruent, and then explain your answer. So they did example A for us, so we're going to use this as a guide when it's time to do example B. It says that the two figures appear to be the same size and shape, so we're going to look for some type of rigid transformation that will prove, okay, all it was a reflection or a rotation or translation, and then we can say, yes, they are congruent because the points would match up. Okay. All right, so this one, they said that you could map this one to this one by reflecting it across the y-axis, right? So the two figures are congruent. The coordinate notation that would show that, if you reflect across the y, would change the sign of x. Okay? So we're going to have to do something like this. Come up with what transformation is happening to prove that these two are congruent. Okay, so on B, it says, these two figures appear to be same or different. Okay. So, if they're the same, that means I should be able to map triangle ABC to triangle XYZ in some way. Okay. So what transformation would have to happen for ABC to map to XYZ? Rotation of how many degrees? Okay. So rotation 90 degrees, which direction? Counterclockwise. About the coordinate point O or 0 or whatever, right? If this must have been the center if it ended up there, right? Because if we went here, we only went.
I thought we were going this.
Yeah, ABC, it says we're mapping ABC to XYZ. Okay. And it must have been rotated around the origin for it to end up there, right? Okay. And I think they can't tell if that's a 0 or no, but either way, about 0 or 0.0, whichever that is. Okay. So it says this is or is not a rigid motion that maps ABC to XYZ. It is. Good. So the figures are or are not congruent? Are. All right, and then they just want us to write in coordinate notation what happened. So I had my original point XY. If I make a 90-degree rotation counterclockwise, what happens? Good. Okay. All right, exact same thing on these two right here. They want us to kind of make statements like what we just filled in the blanks for. Okay, so it says use the definition of congruence to decide whether the two figures are congruent. So on 2, are we thinking they look congruent? Okay, so then by what method of transformation could we prove that? Okay, so we could say A, B, C, D can be mapped to W, X, Y, Z by a reflection over the x-axis. And if that's the case, then therefore, this is the symbol for therefore. It's like 3 dots to make a triangle. The shapes are congruent. Because reflections preserve congruence. Okay. Okay, same idea here on number 3, right? So we need to come up with some type of transformation if we think they're congruent. Do we think they're congruent? Okay, what kind of transformation could prove that? Reflection over what?
Over x equals negative.
Very good, very good. So triangle JKL can be mapped to triangle XYZ by a reflection over x equals -3. And then you would just copy and paste basically what we said at the end over here, right? Therefore, they are congruent. And you can just put it here, same as number 2. Right? Because they are being reflected, reflection does hold congruence. Okay? All right. Okay, last page. Says that the definition of congruence tells you that when two figures are known to be congruent, there must be some sequence of rigid motion that maps one to the other. So here it says the figures shown are congruent. So they're telling us right now they are congruent. Find a sequence of rigid motion. So this time it's not just going to be one change that's happening. It's going to be a few in a row, kind of like the combination notes that we just finished. Okay. So it says that ABC and PQR are congruent. They want us to map ABC to PQR. So it says that on this one, it rotated 180 degrees, right? That would take it and put it here. All right, and then they did a horizontal translation, right? Because it wouldn't have quite been in that specific point. They just shifted it right 1 unit afterwards. Okay, so this is what we're going to be looking for. We're going to want to be able to come up with the 2 or more transformations that may be happening in our figure. Okay, so on example B, the one we're supposed to do, we're trying to make ABCD map to JKLM. So what would I have changed about this one to get it to end up here? Okay, well, first of all, are they on the same side of the axis? So how would this one have ended up facing that direction over there? A reflection, okay? Reflection over what? Okay. Okay, which would have put it looking just like this, just up here somewhere, right? And how would I have gotten it to move from up here to down here? Just translation. It would be this figure slid down. I wouldn't want to flip it again because then it wouldn't look the same. Okay, so followed by a translation. Okay, so for the reflection, we start with our XY. What's the only thing that's going to change? Right, change the sign of your X. Good. All right, so that would have flipped this over. Okay, then for our translation, again, we start with that original point. So if I reflected this across, it would have been like here for B, right? Okay, well that's supposed to line up with K. So how much did they move it over? Okay. Oh, did I count right? Is that right? Okay. So So B was at 1.5, so across would be 1. Okay, alright, just wanted to make sure. Alright, so then I would put that it shifted left or right? Right. 1 unit. Alright, and oh, this is in increments of 2, isn't it? 2, 4. So this would actually be plus 2. Sorry. Didn't pay attention to our units. Alright, and then it moved down, guys. Down 1, 2, 3, 4, 5, which is actually 10. So y minus 10. Okay. Okay, then it says, how is the orientation of the figure affected by a sequence of transformations? Okay, so in this specific problem, when we reflected it, what changed about the figure? I think I heard somebody say it.
Location of position.
Orientation, right, because it was facing a different direction once we flipped it. So the figure's orientation will change with the reflection. And then we translated it down, right? So that part is what's going to change its what? Location. Okay. And location will change with the translation. Okay, last two here. It says that the figures are congruent. They just want us to come up with the sequence of motions that maps one to another and write those in coordinate form. Okay. So on this one, JKLM to WXYZ. So first, what would I have had to change about this one to get it down here? Okay, so reflection over. Now, if I reflected it over the x-axis, K would have ended up on this line, right? Or we could say that it reflected across this line, right? And that would have put it in that spot. Okay? So reflect across the y equals -1. Okay? And then, like you said, the second would be a translation. We had our original coordinate point, so I would have now ended up right here. How would I get from here to my other point? Left to, but really that would be 4 on this graph, right? Okay. Okay, so then we would have x minus 4y. Good. Okay. All right, last one. We're doing ABCD to PQRST. So again, the first thing we probably notice is some type of reflection. Okay. Now the end was pointing this way, and now it's pointing this way. So I didn't flip down; I flipped across. Flipping across is across what? The y-axis. Good. So reflection over y-axis. right? And if I reflected directly across, all that would have changed is the sign, right? It would have still been up here. So it obviously has been shifted down some amount, right? How much was it shifted down? 10, right? So then it was shifted by translation. Of xy to x and then y minus